So I got cut off in the last video. I have a 5-minute limit there, so I wanted to walk through this sample problem here. So again, we're looking at different substances and we're trying to determine what kind of crystalline solid do we have. And as I was saying, iron is just an element and iron is metallic. So iron is an atomic metal. Therefore, the iron is a metallic crystal or metallic solid with metallic bonds holding those atoms together. So that's the process that we go through. Calcium bromide, it's an ionic compound, and so it's going to be an ionic solid or an ionic crystal held together by ionic bonds. So these things are not that difficult if you can determine what kind of substance we're dealing with. Iodine is an element, but in that case, iodine works out to be molecular, and if it's molecular, it's going to be nonpolar because atoms of iodine are being held together. They have the same electronegativity, so there's not anything different. So it's going to be a molecular nonmetal, and it's not polar, and so it's going to form a molecular solid, and dispersion forces are going to be holding that together. Finally, sulfur dichloride, it's a molecular compound. That molecular compound works out to be polar because that molecule is going to have a bent geometry. Chlorine has a higher electronegativity than sulfur, and therefore you're going to have a polar molecule. So a molecular crystal is going to form because we've got molecules, and because it's polar, the dipole-dipole interactions are going to be the strongest force that is interacting.